Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class I'll teach you laws of motion, Newton's second law and impulse. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET exam confidently with a good rank. Now let's start about the class. Newton's second law actually measure the measurement of the force. How force is numerically calculated. We learn how force is calculated and how force derivation of force comes from Newton's second law. Suppose a body of mass m is moving. Suppose body of mass m is moving with velocity u, and a force is applied on the body for time t. T is the time of duration for which the force acts. Okay. Now after t second, the body changes its velocity. That is, after t second, the velocity of the body become v. Now here change of momentum, what's change of momentum we know equal to final momentum minus initial momentum as the body moves in same direction. So just we take the scalar quantity, change means this, just we take the scalar quantity and change is mv minus mu, change of momentum. Now this change of momentum occurs in t second. So what is the rate of change of momentum? Rate of change of momentum equal to mv minus mu by t. So from Newton's, what is Newton's second law? Rate of change of momentum is proportional to force. Force is proportional to rate of change of momentum. This. So this equal to m into v minus u by t. Constant term is present here. Now this is equal to k m a. So f equal to k m a we get f equal to k m a. Now what is the value of k? From definition of force, from definition of force, definition of force, from definition of unit force, from definition of unit force, if a force acts on unit mass produces the acceleration of meter 1 unit per second square, that is acceleration equal to 1 meter per. If we take body of mass of the body is 1 kg, then acceleration should be taken as 1 meter per second square. Then the force is 1 unit, that is, if this is f equal to 1, when m equal to 1, a equal to 1, f 1 equal to 1, from so k equal to 1. So this we get from definition of force, unit force, definition of unit force, k equal to 1. So f equal to m into a. This is the force mass acceleration equation, f equal to ma. So when a single force f acts on a body of mass m, acts on a body of mass m, it produces the acceleration a, and the relation between force, mass, acceleration is this. Now SI system, standard international system, 1 Newton, and in CGS system it is CGS system. Now what is the relation between Newton and dyne? 1 Newton equal to 10 to the power 5 dyne. Now this is called absolute unit, and another unit called gravitational unit, which is equal to 1 kg force. 1 kg force. SI system gravitational unit, one kg force or 1 kg weight in SI system, and 1 kg 1 gram weight gram force or 1 gram weight. This is CGS system. This is CGS system. So the weight equal to 9.8 Newton and 1 gram weight equal to 980 dyne 980 dyne and 1 Newton equal to 10 to the power 5 dyne. So these are the unit of the force. Another important term is impulse. Impulse is denoted by J, equal to force into time into T, or impulse equal to product of force into duration for which force acts. So simple, we know, we define impulse equal to force into time. Now F equal to m v minus u by t. So F into t equal to mv minus mu. That is impulse equal to change of momentum. That is final momentum minus initial momentum. This is impulse. This is ft. If a constant force acts for t second, then area under ft graph denote the impulse. So here impulse equal to area under ft graph, because f is here and t is here. So if body starts with velocity 20 meter per second, find the velocity after 4 second. This is given. So here this is Newton, this is second, t for second. So here the answer will be, if body starts with velocity this, find the velocity after 4 second. So here the theory is change of momentum, that is impulse. Change of momentum, that is impulse, equal to area of ft graph. So area equal to half base is 4 and height is 10, which is equal to 20. So change of momentum is mass. Here body of mass 2 kg suppose. Now mass is 2, velocity final minus initial is 20 equal to 20. So v equal to 30. This is the answer. Now another term is impulsive force. What is impulsive force? When a large force acts for a short time, that force is called impulsive force. Example, suppose kicking a football or striking a ball with a cricket bat. This type of is impulsive force. That is, contact force between bat and ball is very short. So when a cricket ball is struck by bat, then that type of force is called impulsive force. Or kicking a football with a foot. So this is the example of impulsive force, striking a ball with a bat. So if short time of contact we cannot know, but if the change of momentum we know, then we can calculate the time of contact, etc. Striking a ball with a bat or kicking a football with a foot. Are the example of impulsive force. Now, impulse for variable force. What is impulse for variable force? Suppose this is force, this is time, and a force is vary with time t. This is that is force is the function of t. Now we know the area under ft graph is impulse. So here suppose from t1, this is t1, this is time t2. Now what is the impulse within the interval t1 to t2? Now we know the area here, area becomes this. So if we draw a stripe on the time axis, this is dt, and at the time this the height is ft, f is the function of time, so this is ft and this is dt. Now what is the area of this? Area dA equal to ft into dt. This area is this. Now what is the total area? Total area from t1 to t2 equal to dA integration. We take this is lower limit and this is upper limit. So dA and dA equal to ft dt t1 to t2. So ft is the function of time. It is given in question. Generally it is given to question. So this is the theory. Total area equal to ft dt. So this is the change of momentum or impulse. For example, varies with time according to the relation f equal to suppose 2t. Simple example, force equal to 2t. Find the velocity of body after first 3 seconds if body starts with rest. This is the question. If force varies with time according to the relation this, find the velocity of body after first 3 seconds. After first 3 seconds, if body starts with rest. So what is the solution? Solution equal to, we know area of ft graph, that is impulse. Solution becomes, we know impulse j equal to integration of f dt t1 t2 means here first 3 seconds means 0 to 3. Here time interval becomes 0 to 3. So this 2t dt 0 to 3. So this is the 2 integration t dt is t square by 2, that is 9. Now impulse equal to change of momentum. Here force is here mass. Force varies with time according to the relation. Find the velocity of body of mass 3 kg. Mass is given 3 kg. So this is equal to impulse. Now impulse equal to change of momentum. So m v minus m into u equal to 9. M equal to 3. V minus 0 equal to 9. So velocity equal to 3 meter per second. This is the answer. Now here some question is given. In the given figure, the position time graph, the position time graph of a particle of mass 0.1 kg is shown. The impulse at t equal to 2 seconds is what? Here position time graph is given at 2 second, what is the impulse of the body? What is the impulse of the body? 4 option is correct. Which one? Now solution of this, solution of 1, problem 1. Now in this, at 2 second initial velocity and final velocity, at 2 second initial velocity and final velocity, two velocity are to be calculated. Initial velocity, we know slope of the xt graph, slope of the xt graph equal to velocity. So u equal to slope of xt graph, position versus time graph equal to velocity. So this equal to 4 by 2, 4 by 2, that is this 2. Now what is the final velocity? Final velocity becomes, that is slope of this curve is 0. So final velocity v equal to 0. Now change of momentum, mass is 0.1 kg. So change of momentum del v equal to m into final velocity minus initial velocity. Magnitude, we have to take the magnitude 0 minus 2. So magnitude of this is this, that is 0.2 kg meter per second. Mass into velocity kg meter per second. Okay, so this is the answer, 0.2 kg meter per second. Mass into velocity in 2 second. In 2 second, just we have to calculate two velocity, initial and final. Two velocity are to be calculated. Initial velocity u equal to slope of xt graph. So here the slope is tan theta. We know tan theta equal to slope equal to perpendicular base, perpendicular 4 unit, base 2 unit, 4 by 2, that is 2. Now v is the slope of this line, final velocity, which is parallel to the t, so slope is 0. Now change of momentum equal to mass into change of velocity. So this is the answer. Now second, mass of the body is given, and in 1 second what is the impulse? Now we know this is initial velocity and this is final velocity. So change of momentum equal to impulse equal to mass into final minus initial. Mass equal to 2 kg and final velocity, slope of the this graph, which is equal to perpendicular by base 6 by 2, and this is negative slope, so velocity will be negative, minus initial velocity equal to slope of this graph, which is equal to 6 by 1. Now this slope is 6, interval is 1, time gap is 1, so perpendicular is 6 and base is 1 to 2, that is 1. So velocity equal to this, and initial velocity also same. Here velocity will be negative slope, and initial velocity will be positive slope, so this is negative. So this is the answer. Now the initial velocity, this gap also 1, so this is 1. So this is the answer. Now magnitude of this velocity, magnitude of the impulse, we get 24 kg meter per second. If this is meter, kg meter per second, this is the answer. Now third question is here. What is the third question? Like the vertical wall at an angle 60 degree with the vertical, this angle 60 degree, and rebounds with same velocity or speed. Suppose speed is 20 meter per second, that is speed does not change. The time of contact between body and vertical wall is 0.2 second. Time of contact is given. Find average force exerted on wall by the ball, exerted on wall by the ball. This is the question. Find average force exerted on wall by the ball. So I draw the problem once again. Suppose this is a vertical wall and the ball strike here and rebounds this. So this angle is 60 degree. This is 60 degree. Now mass is given. So here we have to here we have to resolve the velocity along two direction, horizontal direction and vertical, and this also horizontal and vertical. Now if this angle is 60 degree, then we get this is 60 degree. So this component will be v sin 60 degree and this is V cos 60 degree. Again this is V, so 60 degree means this 60 degree, so this is V cos 60 degree and this is V sin 60 degree. So along vertical direction, no change of velocity. Along vertical direction no change of velocity because V cos 60 degree and V cos 60 degree. Magnitude and direction both are same along vertical direction. Both magnitude and direction are same. Now in horizontal direction, change occurs in the direction. Here this is positive, here in this direction velocity acts in this direction, here in this direction. So along horizontal direction change of momentum del P equal to what? M mass of the body 10 kg, M V. If we take this is positive, then this is suppose okay, this is vector quantity. If we take this is unit vector I, then this is unit vector minus I. So mv, that is m v sin 60 degree. V is what? V is 20 sin 60 degree. With we have to take with vector. This vector is minus I, minus initial momentum mass into plus I. So what's the result? Now this del P equal to minus 200 into 2 sin 60 degree. Okay, so this the magnitude of this is I, magnitude of this equal to this. So this is the answer. Change of momentum. Now what is the average velocity? Average velocity exerted on the wall. We know force equal to change of momentum by time. So change of momentum equal to 200 root 3 and time becomes 0.2 second. What is the time? So just time you divide the time, you get the average force. Acting on it. So here we have to resolve the velocity along two directions, horizontal direction and vertical direction. Here horizontal and vertical. We see that no change of velocity along vertical direction. Magnitude and direction both remain same. But in horizontal direction, we see that only magnitude remains same, but direction is changed. So if we write the momentum mv minus mu, so we take a unit vector along this direction. This is plus I. If this is plus I, then this should be minus I. So change of momentum, final velocity, final momentum, mass into velocity with direction minus I. Here final velocity is in this direction, and minus change means here minus should be placed here middle into minus initial velocity, initial momentum. So if we calculate this, then magnitude of this, now average force equal to change of momentum by time. So this is the answer. What is the conservation momentum? If no external force is applied on the system of moving body, then total momentum remain same after collision and before collision. This is the conservation of momentum. Suppose a body of mass m1 moving with velocity u1 and another body m2 moving with velocity u2. So two body collide here. During collision, this body strike this body, apply the force on this, and this body applies this force. This is Newton's third law. Newton's third law will be discussed in another video. Now what is the change of velocity? Velocity of the two body be changes after collision. Here collision take place. Now linear momentum, conservation of this is linear momentum. So linear momentum is theory is this. This is conservation of linear momentum. So condition is external force, no external force acts here. Here collision take place, but this is internal force, no external force. If external force act on the body, then this law does not hold. Okay, does not hold. If x becomes 0, then momentum along x direction constant. Px is momentum along x direction, and if Fy equal to 0, Py equal to constant. So if Fy 0 and Fz 0, then Pz equal to constant. In XYZ system, if force along x direction 0, then momentum along x direction is constant. Before and after, if y equal to 0, so this way. Now explosion, during explosion, initial momentum of bomb should be taken 0. Now if a bomb explode and three parts, one part move. If a bomb explodes and two parts move perpendicular to each other, then what is the velocity of the other parts? Suppose two part this moves with velocity this and this, and the mass of, suppose mass of bomb is 5 kg, and it is divided into 1:1:2, 1:1:3 in this ratio. That is two mass here equal part, and third mass is this in this ratio. Mass of bomb is 5 kg, and it is divided into two in this ratio. It is divided with this ratio. Now what is the velocity of the third part? Suppose this is, now total mass is 5 kg, so mass of this is 1 by 1 plus 1 plus 3 into 5, that is 1 kg. So this is 1 kg, this is 1 kg, and this is 3 kg. Now if the two part moves perpendicular to each other with a velocity this and this, what is the velocity of this? Momentum is a vector quantity, so del p equal to constant, means del p initial momentum is 0 and final momentum mass into velocity momentum, that is p1 px. If we take this is along x axis, this is y axis, and this is not defined, so px py plus p equal to 0. Now p equal to magnitude of this. If we take minus will be cancelled if we take magnitude. Now mass into velocity, so mass into velocity, and this is 30 into 1 I. Suppose this is I, and 30 40 py equal to 40 into 1 into j, so 3v equal to root over 30 square plus 40 square, which is equal to 50. So v equal to 50 by 3. Recoil velocity of gun. Suppose mass of the gun is m, and a bullet fires, mass of the bullet m. When the bullet fires with velocity u, what is the velocity? Recoil velocity of gun. V what? M is mass of bullet, and capital M is mass of gun. U velocity of bullet and V velocity of gun. So what is the velocity of gun? You have to calculate. Now here, when firing take place, then initial momentum of system means bullet and gun both. Initial momentum equal to final momentum. Initial momentum is 0. Final momentum m into u plus capital M into V. So V equal to minus mu by m. So this is the magnitude of the recoil velocity, mu by m. Okay. Student, this is the end of the class today. To get such type of video, subscribe my channel. Okay, thank you.